Let's look into the concepts, examples, and problems under exercise set 2.4 under Introduction to Linear Polynomials. Let's look into the linear growth and linear decay in case of linear relationships. So this linear expressions help to model situations of phenomenon where there is a growth or decline. So in case of linear relationships, either the value increases at equal intervals by equal values, or it decreases by equal values at equal intervals of time, then it is called as a linear relationship. So this linear relationship can fall under an incremental pattern, that is a linear growth, or a decremental pattern, in which case we call it as a linear decay. So with the help of few examples, let's try to understand how it goes. Example number 9. The cost of a journey is given by the linear function C of D is 100 plus 60D, where C indicates the total cost in rupees and D the distance traveled in kilometers. Let us make a table of values for D varying from 0 to 10 kilometers and show how the cost increases for every kilometer. If you look into the tabular column, so for every kilometer, the cost incurred, the value is given. Say for example, for 0 kilometers, it's 100. For 1 is 160, 2 is 220, 3 is 280, and so on. So in this example, as we can see very well, if the value of D increases by 1 kilometer, then the value of the cost function will increase by a fixed amount of 60. That we can make out very well from the values, right? 160 minus 100 is 60, 220 minus 160 is 60, 280 minus 220 is 60. So there is a constant increase by 60 rupees for each and every kilometer as the kilometer progresses by each step. So this kind of an example, you will call it as a linear growth. Now, what will be the cost for traveling 15 kilometers? For how many kilometers will be the cost of the journey? Be 700 rupees. So, the first question will be for 15 kilometers, what will be the cost? We know the linear relationship is C, or the cost function is C in terms of D is equal to 100 plus 60D. Here they have given D the value to be 15. So just replace the values, get the value after substitution, and that will be the cost, that is 100 rupees, as you can see from the worked out example, will be the cost for traveling 15 kilometers. For how many kilometers will the cost of the journey be 700? Now the cost, that is the second row in the tabular column, the value is given as 700. So just substitute it. 100 plus 60D is equal to 700. Just do simple calculation and find out the value of D to be equal to 10 kilometers. So what do we mean by that? The cost of the journey will be 700 rupees when you travel 10 kilometers. That's what we infer from this example. Let's look into example 10. This will be an example of a linear decay. Previous example, we saw what is a linear growth. This will be a linear decay, meaning there will be a consistent decrease in the value as the time interval progresses. So the height of the water in the cylindrical tank is 3 meters at the start of summer. The height h meter at the end of t means is given by the linear function h of t is equal to 3 minus 0.5 t. So for every month, the height of the water seems to be decreasing. That we can make out from the tabular column. In the example above, as the value of t increases by a fixed number, that is month by month, the value of the height decreases by a fixed number. What is the fixed number here? 0.5 meters. Therefore, this example represents linear decay. What will be the height of the water at the end of 5 months? The linear expression will be h of t is equal to 3 minus 0.5 times t. When t is 5 months, then h of 5 is equal to 0. Substituting the values, we get 0.5 meters. So at the end of 5 months, the height of the water will be 0.5 meters. So, mm, these two examples are typical representatives to show how there will be incremental growth or incremental decay, which will be a constant value at equal intervals of time when it has to represent a linear relationship. That's what we are expected to appreciate at this moment. So, the definition goes as the linear growth describes a linear pattern where a quantity increases by a constant amount over equal intervals. Similarly, linear decay describes a linear pattern where a quantity decreases by a constant amount over equal intervals. So we should be keen about the keywords being used: linear growth, linear pattern, increases or decreases, constant amount, equal intervals. These represent a linear relationship. Problems under 2.4. Question number 1. Suppose a plant has height 1.75 feet and it grows 0.5 feet every month. Find the height after 7 months is question number 1. So, the initial height from where we are expected to calculate the incremental heights is 1.75 feet. After that, for every month, it grows by 0.5 feet. It grows, it increases. So it's an example of linear growth. Okay, so what could be the linear relationship? 1.75 plus 0.5 times 7. We are expected to find after 7 months when it grows by 0.5 meters for every month. Just replace the values, you will get the value 5.25 feet at the end of 7 months. So question number 2, make a table of values for t varying from 0 to 10 months and show that the height increases every month. So it's just a simple example. From 0 to 10, you have to plot the values in a tabular column and just make use of the varying values of the month from 0 to 10. Substitute it in the linear relationship. Whatever be the value that you're getting will be the height of the plant at the end of that particular month. That we can make out very well from the worked out example. When the value is 0, it's 1.75. When the after 1 month it is 2.25. At the end of 2 months, it's 2.75 feet and so on. We need to calculate at the end of till the end of the 10th month. Now, question number 3, find an expression that relates h and t and explain why it represents a linear growth. Expression relating h and t, meaning we need to find height in terms of t. H of t, we need to find a linear relationship. That is what they are expecting. And we need to show why it represents a linear growth. Just now we understood what a linear growth is and what a linear decay is. This is a particular example of linear growth. Why? The value increases consistently at equal intervals. It goes on increasing. So it definitely is an example of linear growth. So the linear expression will be h is equal to 1.75. It's a constant value. Why? It is the height from when we started to calculate the linear growth. Okay, initially it was 7.5, after which it grew by 0.5 feet at the end of every month. So that constant value is this 1.75 plus 0.5 times t. Why? 0.5 feet it grows at the end of h months. 0, 1, 2, 3, h takes those values. So that is a linear relationship. Now, why do we call it as a linear growth? The height increases by the same height every month, month after month. So the key terms every month, that is the equal interval by the same value. What value it is? 0.5 feet. So we call it as a specific example of a linear growth. Question number 2, a mobile phone is bought for 10,000 rupees. Its value decreases by 500 by 800 at the end of by every year. Question number 1, find the value of the phone after 3 years. The value of 3 years, just initial value, constant value, 10,000 minus 3 times 800 is nothing but 7,600. It is this particular value at the end of 3 years. Make a table of values of t varying from 0 to 8 years and show how the value of the phone depreciates with time. So 0 to 8 years, right? So as is this brand new, just now you have bought, its value is 10,000. So the end of 0 year or even before a year has begun, the value remains at 0. At the end of 1 year, one complete year, the value would reduce by 800 rupees, right? So the value of the phone will be 9,200. At the end of 2 years, it will be 8,400. So we just replace the value in the linear relationship and then find and substitute the values in the table. The third question is the same. We need to find an expression that relates v and t, and you need to explain why it's a linear decay. V is equal to 10,000 minus 800t will be the linear relationship. Now, the linear decay, you need to explain why it's a linear decay. So, you call that linear expression as a linear decay because the value decreases. Decreases is the keyword here, by an equal amount. What is the equal amount here? For this specific example, it's 800 rupees. At equal intervals. What is this equal intervals? Here, every year is the equal interval. So, since there is a consistent decrease over equal intervals of time, you call it as a linear decay. Same as the previous subs. Question number 3, the initial population of a village is 750. By every year, 50 people move from a nearby city to the village. Find the population of the village after 60 years. If people are moving into the city, it's an example of linear growth. By how many people? By 50 people at the end of every year. Like every year 150 people move in, year 2 100 people move in. So based on that, after 6 years there will be 1050 people in the village. So initial population is 750. Number of people moving to the village every year is 50. So we just have to substitute and find out the values. The expression will be the population P is equal to 750 plus 50 times the number of years, or 750 plus 50 times t. This linear expression represents linear growth as the population increases by a constant value across equal intervals. So what is the constant value here? It is 50. Equal intervals, that is by every year, 0 year, 1 year, 2 year, and so on. Question number 4, similar example. A telecom company charges 600 for a certain recharge scheme. The prepaid is reduced by 15 each day after the recharge. Write an equation that models the remaining balance after using the scheme for x days. Explain why it represents a linear decay. The initial amount will be 600. The amount reduced each day is 515. So the linear expression will be 600 minus 15x, which is a typical example of a linear decay. Right. So here, what is the intervals? Every day is the equal interval. What is the equal amount that is being reduced? It's 15 rupees. So after how many days will the balance run out? So the balance should be 0. We need to find the value of x. It's a simple algebraic expression. So 600 minus 15x is equal to 0. Just equate, find out the value of x. So the balance will run out after 40 days. Make a table, very simple. Just replace the values for the linear expression 600 minus 15 times x. Make the value of x to be 0, 1, 2, 3, 4, and so on up to 10. Substitute, find the values, fill in the table or column. That is what is expected in this sum.